Good morning class. Today we are going to discuss about the center of gravity for a 3D objects, and a problem will be solved by both of them.
Good morning guys. Today we will be discussing about center of gravity and centroid. So when it comes to center of gravity, we will be discussing about 3D objects. So say for example, every object in the universe has a mass, right? So when it comes to center of gravity, we will be handling with 3D objects. So say for example, I will take this note. So center of gravity is nothing but a point, okay? It's just an assumption, a point at which the weight of the body is acting. So say for example, I am taking this note and I am taking a point at the center. So a point at which I am just assuming that the weight of this whole object is acting at that point. So that is called as center of gravity. Whereas when it comes to center of centroid, we are handling with 2D objects. So when it comes to 2D objects, we won't be talking about the weight. Instead, we will be talking about the area. So centroid can be defined as the point, an imaginary point or an assumption taken in order to find the area of that particular object is known as your centroid. So this is the major difference between, there is no big difference between center of gravity and centroid. There is only a minimal difference but yet an important difference, which is when it comes to center of gravity, we will be discussing about 3D objects, whereas when it comes to centroid, we will be discussing about 2D objects. So the session will be
Good morning, and the given question is a cylinder of a height is 10 cm and a radius of base is 4 cm is placed under the sphere. A cylinder is placed under the sphere. Then the radius of the sphere is to 4 cm such that they have common vertical axis. Okay? If both of them are made up of same material, locate in the center. We want to find the center of gravity. Okay? Then, and this is the x-axis and this is the y-axis. When we are placing the x-coordinate at the center, we cannot find any symmetry. At the same time, when we are placing the y-coordinate at the center, we can find symmetry. If y-axis is symmetric to the given object, then we can easily found that x bar. For finding x bar, what is here 8 centimeter? 8 centimeter by 2. So, okay. In the sum, we have to find x bar and y bar. This is symmetric to y-axis. Then we easily found that x bar. For finding the y bar, we need this. V1 is nothing but volume of the cylinder. And y1 is nothing but vertical height. Okay. And the same V2 is volume of the sphere. And y2 is vertical height of the sphere. Okay. For finding V1, first we can take cylinder. The volume of cylinder is 5 into radius square into h. 5 value is 3.14 and the radius of the cylinder is given in the question 4 cm and height of the cylinder is 10. Okay. While we are calculating, the answer is
125.6.
again
125.6.
no.
502.4.
For finding y1, what is the length? 10. So 10 by 2. And y1 is 5 cm. Okay. I find the volume of the cylinder
So when it comes to center of gravity, we will be handling a 3D object. So since it is a 3D object, we are finding out the volume. So actually, I find out V1 and Y1. I will be continuing with for the sphere. So as we all know, the volume of the sphere is 4 by 3 pi r cube. So 4 by 3 into pi. The r value is given as 4, so 4 cube. So can you guys calculate also and everything? So it is nothing but 268 centimeter cube. And next come to y2. So here when you see the diagram, like we have circle on the top, the sphere on the top. So it is nothing but here we have 10 centimeters of gap and here it is 4. So it will be 10 plus 4 is equal to 14 centimeters. So now for the formula, so according to the formula, we have found out V1, Y1, V2, Y2. So we substitute and we will find out what is value of Y1. So V1 is 5 out 2.65, and then you have Y1 which is 5 plus V2 268. So when you calculate your final answer will be 8.13 centimeter. So therefore this is the value of your y bar and x bar is 5. So this will be your final answer of this particular question.